ambient ocean soundscape with subtle, echoing waves and distant, ethereal chimes. Narrator, imagine a world untouched by sunlight, where the weight of the entire ocean presses down like an invisible hand, and silence reigns supreme. This is the Mariana Trench, the deepest scar on Earth's surface, plunging nearly 7 miles into the abyss. Located in the western Pacific Ocean, it forms a crescent-shaped chasm that could swallow Mount Everest whole and still have room to spare. At its lowest point, known as Challenger Deep, the pressure reaches over 1,000 times that at sea level, enough to crush most human-made vessels into oblivion. Temperatures hover just above freezing, around 1 to 4 degrees Celsius, in perpetual darkness. Yet, against all odds, life persists here, in one of the planet's most unforgiving environments. How does anything survive in this hidden realm? In this exploration, we'll descend into the depths, uncovering the quiet miracles of adaptation that allow creatures to thrive where few dare to venture. Join us as we unravel the serene mysteries of life at the bottom of the Mariana Trench. Transition, soft, flowing water sounds, building a sense of gradual descent. In the body of our journey, let's first consider the profound challenges that define this hadal zone. The deepest layer of the ocean, named after Hades, the ancient Greek underworld. These obstacles shape every aspect of existence here, forcing evolution to craft solutions as elegant as they are extreme. The most immediate hurdle is the immense hydrostatic pressure. At Challenger Deep, approximately 10,900 meters below the surface, the force equates to about 16,000 pounds per square inch. This is like having 8 tons resting on every square inch of your body. For most organisms, such pressure would collapse cells and disrupt vital functions. Yet life here has evolved membranes and proteins that remain fluid and functional under this crush. Darkness envelopes everything. Below 1,000 meters, sunlight fades entirely, leaving a void where vision as we know it is irrelevant. Creatures must navigate, hunt, and communicate without light, relying on other senses or internal glows to pierce the gloom. The cold is unrelenting. With temperatures barely above freezing, metabolic processes slow to a crawl. Energy conservation becomes paramount, as the chill saps what little warmth there is, demanding adaptations that prevent freezing while minimizing energy use. Food scarcity defines the ecosystem. Nutrients rain down sporadically from above in the form of marine snow, organic debris from surface life. This unpredictable supply means inhabitants must be opportunistic scavengers, capable of enduring long periods without sustenance. Oxygen levels, while present, are low and unevenly distributed. Dissolved from surface waters, it must diffuse deep, but the trench's isolation can create pockets of hypoxia, challenging respiratory systems to extract every molecule efficiently. The sediment-covered floor, composed of fine ooze from millennia of falling particles, offers little structure. It's a soft, unstable substrate where burrowing or anchoring requires specialized forms to avoid being buried or swept away by subtle currents. Now, turning to the inhabitants themselves, we find a tapestry of life forms that have quietly mastered these trials. Microbes form the foundation, teeming in numbers that boggle the mind. Among the simplest are foraminifera, single-celled organisms like xenophyophores. These giants of the microscopic world, up to 20 centimeters across, build protective tests from sediment and sponge spicules. They've been found at depths exceeding 10,600 meters, filtering nutrients from the water with pseudopods that extend like delicate threads. Bacteria thrive in astonishing diversity. Recent expeditions have identified thousands of microbial species unique to the trench, many chemosynthetic, deriving energy from chemical reactions rather than sunlight. These microbes form mats on the seafloor, recycling organic matter and supporting higher life forms in a self-sustaining cycle. Shifting to multicellular marvels, invertebrates dominate, their bodies molded by eons of isolation. The supergiant amphipod, Hirondelia gigas, resembles an oversized shrimp, growing up to 34 centimeters long. It scavenges voraciously, using enzymes to digest toxic compounds and fallen debris, including plastics that have sadly infiltrated even this remote haven. Sea cucumbers, or holothurians, glide across the sediment like living vacuum cleaners. Species like those in the genus Elpidia ingest mud, extracting sparse organics and excreting cleaner sediment, thus aerating the floor and aiding nutrient turnover. Jellyfish and other cnidarians drift ethereally, their translucent bodies adapted to withstand pressure without rigid structures. Some, like the benthochodon, use bioluminescence to lure prey in the dark, flashing soft lights that mimic distant stars. The Dumbo octopus, Grimpeteuthis species, flaps its ear-like fins gracefully, hovering just above the bottom. Lacking an ink sac common to shallower relatives, it relies on camouflage and slow, deliberate movements to evade threats, conserving energy in the cold. Vertebrates, though rarer, showcase some of the most remarkable adaptations. The Mariana snailfish, Pseudoliparus swirei, holds the record as the deepest living fish, spotted at over 8,000 meters. Its gelatinous body lacks a swim bladder, which would implode under pressure, and instead uses a jelly-like composition to maintain buoyancy while resisting compression. Deep-sea dragonfish, with their elongated bodies and fang-like teeth, employ bioluminescence not just for attraction but for counter-illumination, matching the faint overhead glow to hide from predators below. Barrel-eye fish, though not exclusively trench dwellers, have been observed in deep Pacific zones with tubular eyes that rotate upward, scanning for silhouettes against the dimmest light from above, an adaptation honed for eternal twilight. Human presence in this realm, while fleeting, adds a layer of wonder and caution to the narrative. The first descent occurred in 1960, when Jacques Picard and Don Walsh piloted the bathyscaphe Trieste to Challenger Deep. They spent just 20 minutes on the bottom, observing a flatfish stirring the sediment, a quiet revelation that life existed even there. In 2012, filmmaker James Cameron solo-piloted the deep-sea Challenger submersible, collecting samples and footage that revealed microbial mats and amphipods, bridging science and storytelling. Victor Vescovo's 2019 dives in the limiting factor set new records, discovering new species while alarmingly finding plastic debris, a somber reminder of surface impacts reaching the abyss. Robotic explorers, like NOAA's remotely operated vehicles, have mapped hydrothermal vents near the trench, uncovering chemosynthetic communities that hint at life's origins, with tube worms and snails adapted to toxic, mineral-rich waters. Recent genomic studies of trench species reveal shared mutations for pressure tolerance, such as altered lipid membranes and enhanced DNA repair, suggesting convergent evolution in this isolated world. Transition. Ambient sounds deepen, then gradually lighten, evoking ascent. As we surface from these depths, reflect on the quiet resilience woven into the fabric of life at the bottom of the Mariana Trench. In a place where existence seems improbable, organisms have not just survived but flourished through subtle ingenuity, bodies that bend rather than break, senses that thrive in shadow, and metabolisms tuned to scarcity. This hidden ecosystem whispers lessons of adaptability, reminding us that even in Earth's most extreme corners, life finds a way to persist with graceful determination. The trench endures as a testament to the planet's enduring vitality, urging us to protect these fragile frontiers from the encroaching shadows of human influence. As the ocean's deepest secrets continue to unfold, they invite us to ponder our own place in this vast, interconnected web. Closing music swells gently, fading into serene waves.